This is 2016 question 4. The function f of x equals x cubed plus x squared minus 2x plus 7. And you're asked to find the coordinates at which it cuts the y-axis. Now the guaranteed thing about any point on the y-axis is the fact that the x value has to equal 0. Any point on the y-axis has to have an x value of 0. So you're going to get your function and you're going to replace all your x values with 0. And when you replace all these x values with 0, you should get the answer 0, 7. You can also back this up using the table function, where if you try and draw this graph, so you use x cubed plus x squared minus 2x plus 7. And you start at, let's say, minus 10 to plus 10. You'll see that the point where it crosses the y-axis is 0, minus 7, or 0, 7, which is okay here. Now, next thing, to verify that a point is on a graph or a line, you know the x equals 1 and y equals 7. So please remember that fx is just another way of saying y. So this equation is very much just y equals x cubed plus x squared minus 2x plus 7. Replace y with 7 and then replace x with 1. So you're going to get 1 cubed plus 1 squared minus 2 times 1 plus 7. You can put all of this into the calculator, and what you'll end up with is 7 equals 7. And because it balances, because that point balances the equation, it means that that point is on the line. And we also know this from our table function that the point 1, 7 is definitely on the line. The next thing we're asked to find is the first derivative. Find f dash x, the derivative. So what we're trying to find is the derivative of trying to find the derivative of this function here highlighted in green. Okay, you differentiate x cubed, bring the power to the front, and then take 1 away from the power, so you're going to get 3x squared. Bring 2 for x squared, bring 2 to the front, take 1 away from the power. For minus 2x, remember you just simply drop the x. And finally the plus 7, any regular number disappears when you differentiate it, so it turns into a 0 and it's gone. Now, the thing to remember about slope is the first derivative. Okay, and you're asked for the first derivative with an x value of 1. So what you need to do is you need to replace your first derivative with an x value of 1, and that there will find you the slope. So the first derivative is the slope, but we got to replace the x value with 1. Once again, just put all that into the calculator, and you'll get 3. Next thing you're asked is for the equation of a tangent. Please remember that a tangent is a line, so you're basically being asked for the equation of a line. Equation of a line is on page 18 of your log tables, and here is the equation of a line. Now, when you're looking for the equation of a line, you need to know the point that's on the line. The point that's on the line is 1, 7, and you need to know its slope. Now, we already know the slope for an x value of 1. We see the x value is 1. We already know that from the previous question. And if you look at the language of the question, it also says hence. Hence means you're using part 1 to answer part 2. So we actually know the slope is 3. So we have enough information to answer this question outright. So what we can say is it's y, take away y1, which is 7, equals 3 into x minus 1. We multiply that out, we get 3x minus 3 and y minus 7. You can present this in 2 ways. You could present it as y equals 3x, bring the 7 over, and it becomes a plus 7 minus 3 plus 7 plus 4. You could present it as y equals 3x plus 4, or you could bring it all over one side and you could say that 3x minus y plus 4 equals 0. Also acceptable is the minus version of that answer, which is minus 3x plus 4. Sorry, minus 3x plus y minus 4 equals 0. Okay, that's the first question done. So that was question 4 on the 2016 paper. This is now question 8 on the 2016 paper. Kieran has 21 meters of fence. He wants to enclose a vegetable garden in a rectangular shape as shown. Write an expression for the perimeter of the vegetable garden in terms of x and y. Show that y equals 10.5 minus x. All right, so here's what we're going to do. The perimeter is basically, if you run a lap of the field, that's the perimeter. So it's going to be x plus y plus x plus another y. So essentially, it's going to be 2x's plus 2y's, which is x plus y plus x plus y. And that has to equal 21. Now, the goal of the question is to get y on its own. To get y on its own, you need to move the 2x to the other side. So you get 21 take away 2x. Now, you have 2y on its own here. So when 2 goes over the other side, it's currently multiplication because there's nothing in between the 2 and the y. You can't see anything visible between the 2 and the y. That means it's being multiplied. When you bring it over the other side, it means division. So it's going to be 21 divided by 2 and 2x divided by 2. And 21 divided by 2 is 10.5. And 2x divided by 2 is x. And that proves what we were looking for a second ago. Now, we're on to B. Now, we know that y equals 10.5 take away x, right? So here's what we're going to do. When the x value is 0, the y value is 10.5. When the x value is 1, the y value has to be 9.5. Because remember, it's 10.5 take away the x value. The next one will be 10.5 take away 2, which would be 8.5. Then take away 3, 7.5. So you can see there's a bit of a sequence going on here. Just keep taking away 1, and you can fill it in all the way across, like so. And finally, you end up with 10.5 take away, what's it, 10.5 take away 10, which is simply 0.5. Okay. Now, to get the area, you multiply length multiplied by width is your area. And obviously x is the length and y is the width. So we need to multiply the two of these by each other. 0 multiplied by 10.5 is simply 0. 1 multiplied by 9.5 is 9.5. 2 multiplied by 8.5 is 17. 3 multiplied by 7.5 is 22.5. 4 multiplied by 6.5 is 26. 5 multiplied by 5.5 is 27.5. 6 multiplied by 4.5 is 27. 7 multiplied by 3.5 is 24.5. And 8 multiplied by 2.5 is 20. 9 multiplied by 1.5 is 13.5. And 10 multiplied by 0.5 is 5. So this is the area for each one. Okay. Now we're going to have to draw this graph using these points here. So it's the area on the y-axis and the x value on the x-axis. So we're going to write down the points. Okay. So the first point will be 0, 0. The second point will be 1 and 9.5. The third point will be, 2 and 17. Then we also have 3 and 22.5. We have 4 and 26. We have 5 and 27.5. We have 6 and 27. We have 7 and 24.5. We have 8 and 20. We have 9 and 13.5. And finally, we have 10 and 5. Okay, and these are the numbers we have to draw out. Okay, so please remember, on the grid, it's gone up in units. 2 blocks is worth 3. So this means that 1 block is worth 1.5. So it's technically gone up in 1.5, 1.53, 4.56, 7.5. So we have to be aware of that when we're drawing the diagram. Okay, guys? So let's begin. Let's begin with 0, 0, which is this one here. Okay, now let's reduce the size of this graph. Get a bit more accessible, right? So, and keep your points small as well. 0, 0. So then we get 1 and 9.5. 9.5 is just a bit above 9. And then we have 2 and 17. So please remember 16.5 would be the midway one, so just above that. We have 2 and 17. Then we have 3 and 22.5. 22.5 will be actually dead center there. So that's 2 and 22.5. 4 and 26 be just above 25.5, so about there. 5 and 27.5, just above the 27 mark. 6 and 27 should be this one here. 7 and 24.5, which should be just above the 24 mark. And then 8 and 20, which will be, that'd be 20.5 this line, so that'd be 8 and 20 around there. And then finally 9 and 13.5, 13.5 is about here. Right, so that there is our graph drawn. Just a matter of linking up the parts, and you see a standard N-shaped graph with a maximum at the top. Okay. Make sure it goes through all the points, guys. So you can see there would have lost marks there because it didn't quite go through the point. So you have to make sure you go through every point on the diagram. Okay, there we go. Now, next one. Use your graph to estimate the maximum value of A. Okay, so my maximum value of A is the top of my graph, and I would call that roughly 27.5 or 27.6 because it goes above 27.5. So call it 27.6 or 27.7. Your call. Okay. Now, what width does that? What x value does that happen at? Okay, so we need to find the x value is the length. Okay, so where does that happen? Where is the maximum? Okay, is what we got to look at. So we go downwards. So we say it happens roughly around here. And I think we're talking about a 5.5 width. Okay, so we go for 5.5 length because the x value is 5.5. And that means the width would be 10.5, take away 5.5, which would be around 5. Okay, now from what I know from these questions, I'm pretty sure the answer is actually a square of 5.25 and another 5.25. So I think both answers are actually 5.25 and 5.25, but you're actually allowed a small error in these graphs because at the end of the day it does say estimate. All right, now show that the area of the rectangle can be written as this. No bother, because the length is x and the width is 10.5, take away x, so its area is length multiplied by width, which is 10.5 take away x. If I multiply this in, I'm going to get 10.5x take away x squared. Cool about it. Next thing it's asked me for is the derivative of my answer. So I'm going to differentiate this answer right here. And when you differentiate an x, you just drop it, so you get 10.5. You differentiate an x squared, you get minus 2x. Right, and that is my derivative for D part 2. Now, please remember, when you're talking about maximum values, you're talking about the slope being negative. the slope being equal to 0. So it's positive in this area, but at the very top where the maximum takes place, the slope has to equal 0. So this means our first derivative is equal to 0. Two x equals 0. So move the 2x to the other side. You get 10.5 equals 2x. Divide by 2, and x equals 5.25. Right, and that's your answer. Now, to find out what your area is, well, we have a formula for the area. Here it is here. 10.5 multiplied by 10.5x minus x squared. So area equals 10.5x minus x squared. So what we can do here is we can do 10.5 multiplied by x, which is 5.25, take away x squared, which is 5.25 squared. Okay, put that into your calculator, and we'll find that it's 10.5 multiplied by 5.25. 5.25 squared. 27.5625. And that is our maximum area. Okay, guys, that is the full question. Happy days.